So I have told you the problems we were facing, and now we will try to reduce these problems by a good way of error handling. So once more we'll just go for a simple deployment. Okay, you can see there is get money, which will take the money, withdraw, anybody can withdraw. So we will be focusing on this problem that only the owner can withdraw money. Next, we'll check the balance. So these three things are there, which we will check out over here. So now let's get started. So now we will write a require statement. And the requirement is that owner should be equal to msg.sender. So how do we do this? That the owner can only withdraw money. So we will have to first make a variable which will store the address of this owner. Let's call it address public owner. And now we'll make a constructor. Constructor is also a function which is called at the deployment. So constructor parenthesis, you have to make the constructor public. Next, owner will be equal to msg.sender. So msg.sender will give you the address who has deployed the contract right now or who has started the transaction. So we are up till here, constructor. Okay. Now, once this is set, the person who deploys his address will be stored in owner variable. Now we have to check over here owner equal to msg.sender. That means the person who owns this smart contract or the deployer should be, his address should be equal to the person who is calling this function. So this is a require statement, and if not, if this is false, then this will happen. Now what we can write is that you are not the owner. You are not the owner. So this is how require works. And let me tell you how the revert works. So the revert can be, it is basically an if else kind of statement only. So we will put a if condition out here. We'll do the same thing for get money, that only the money can be sent by the owner into the smart contract. So we'll put the same condition, but in the opposite way. Now in the revert function, we are calling it when the condition is false. So now we will write it as if owner not equal to message.sender, not equal to message.sender, which means that the person who is calling this function is not the person who has created this contract. So if this happens, then just call it revert with some statement. We'll just make it a bit different. We'll this time write it as not owner. Okay. So I've told you about the require, I've told you about the revert. I'll tell you about the assert after this. So let's deploy it. So now first I have created this contract from this account. We'll go to some other account. We'll try to give some money to this. Let's call 13 ethers. Okay. Get money. You can see there is a revert statement and it shows that not owner. That means the person is not the owner. And his funds are not decreased, only the gas fee is reduced. Though the rest of the gas is reverted, but some gas is used. So now we'll go to the owner. Now we'll try to give some ethers. Let's say 10 ethers. Get money. Okay. Check the balance here. Can check the owner 0xb2a out here. Next, we would like to withdraw. Let's try to withdraw with some other account, but we'll give the address of the owner only. Let's try this. Okay, and then comma the amount. Let's say 5 ethers. We'll copy it just because it is in way and paste it, and we'll change this as from 10 we'll change it to 5. Let's try to withdraw. Okay, so we have done the withdraw from the main address or the owner's address. That's why it is working. If we try to do it from the other person's address, let's try withdraw. Okay, reverted due to you are not the owner. So this is called. So you can see we have done the revert, we have done the require. Okay, so we'll reduce some functionality of this. Okay, so we'll just remove this to.transfer, which will actually not transfer the funds to the person out there. It will just decrease the amount. Let's remove this address also, this parameter. Okay, so withdraw will now only reduce the amount but not give the person any money. It will only reduce the balance. So now let's try what happens. Deploy. Let's say we'll again put 10 ethers. We'll check the balance first. 0. Get money, then balance. Okay, you can see it's 10 ethers. Now we will try to withdraw it. What we can actually do is, okay, you have checked the balance out here right now. Now what we will do, we'll copy the whole thing and we'll put it more than this. Let's call 17 ethers. Then we'll withdraw. Let's see what happens. The transaction is successful. That means balance has been reduced by 17 ethers. But now you can see there is the balance as uint. So it cannot take negative numbers. So now we'll check the balance. So this is this big value. Why? Because it has gone through a wraparound, which means that if the 0 has come and then it goes to the negative side, it will not go to the negative side, but it will go to the highest limit or the highest range of it and then start subtracting from there. So this is a very big problem in this. So how can we solve it? We can solve it by an assert statement. You remember that assert is always used for the variables invariance to check that nothing from the compiler side has gone wrong. So we will check that the amount which is given by the user is less than the balance, then only this will get subtracted. So we will write it as assert balance always greater than amount. Can be greater than equal to also. It doesn't give out any string like this require has given out. It won't give out any string. It will just take up all the gas and throw an error. Let's try this out. Deploy. Deployed successfully. Let's give out some money. Let's give out 10. We'll check the balance. Okay, so 10 ethers. Let's try to withdraw 2 ethers first and check if the withdraw function is working properly or not. Withdraw. Okay, we'll check the balance. Yeah, 8 ethers. So it is working perfectly. Now we will do for the 10 ethers and the balance is less but the amount is more. So let's check what happens. Withdraw. Okay, you can see out here transact to error handling withdraw VM error, which is a virtual machine error, invalid opcode. So this is basically thrown from this assert. So now we have covered the require, revert and assert, all 3 types of error handling. Now furthermore we can increase it to the modifiers. Now we will declare simple modifiers. Now what does these modifiers do? Modifiers will check it as a precondition. So how to define modifier? Write the modifier keyword, some name, let's say only owner, so that only the owner can do this transaction or call the function if this only owner is applied. So modifier only owner. And what is the condition? The precondition you want. So we will take out the precondition from here, require. We'll copy it. We will paste it. Let's delete it from here. Okay. And then you should have a placeholder. This is a placeholder, the underscore. So what this will do, if you apply this only owner to any of the functions out here, let's say you have applied it out here, so all the function body code will directly get copied out here and then it will be executed within this. So this is how the modifier works. Now let's try it without putting the modifier and with, like, after putting the modifiers. Let's try to deploy it. Deploy. Let's send some ethers. Let's say 5 ethers. Get money. Okay, and the basic part, as I have removed the required statement from here, anybody can withdraw money. Maybe I should have put an address also. Let's put an address also. Okay, actually we don't need it. Okay, it has been deployed. Let's send some ethers. Get money. Let's check out the balance. And let's check the owner. So here owner is 0xe67. Let's check it out here. Okay. Now let's try to withdraw first 2 ethers. Let's say 2 ethers. Right now the owner is doing it. Okay, withdrawn successfully. We'll check the balance. Okay, 3 ethers. Now we'll go to some other account and try withdrawing it. Some other account. Now let's withdraw more 2 ethers. Let's see the status. Okay, so it has been confirmed well. Now we'll see the balance. It is 1 ether. So anybody can call the withdraw function. Now to put that only the owner can call it, we'll put the modifier out here after the public. Just write the name of the modifier. Okay, now again we'll deploy it. Let's deploy. We have deployed it from the 0x56. Let's go for it. We'll send some money. Let's say 5 ethers. Get money. Let's check the balance. We have 5 ethers. Now let's send 2 ethers firstly from the owner's side and then from a non-owner. Let's change it to 2. Okay. Now we are on the owner. You can check it, 0x56. 0x56. Okay. Now we'll try to withdraw it. Let's check. Okay, withdraw done. We'll check the balance. Okay, correct. Now let's go to the non-owner. Let's go to E67. Now we'll try to withdraw more 2 ethers. Let's see what happens. Yes, you can see that there is a VM error, the virtual machine error. It has reverted and it's saying that you are not the owner, which means this has been called, you are not the owner. And if you just open this is the transaction details basically. I'll just expand the view. I'll talk more about this in one of my next lectures. So you can find here the gas and all values. So you can see that the execution cost is very less right now due to the revert statement, which has given the gas back if anything was extra and all. So I've told you about the revert, assert and require and how the modifiers work. That's all for it.